over the two questions that you had yesterday. In triangle SCU shown below, points T and O are on SU and CU respectively. Segment OT is drawn so that C is congruent to OTU. So I give you a little hint. I said reorientate the triangles and map out all the corresponding parts. So let's get rid of this and let's take a look here. So I wanted you to reorientate them for a specific reason. So if I take this triangle here, right? Let's see. And I'm going to pull it out. This is T, this is U, and this is O. And they said C, right? This guy here, C, is congruent to OTU. So OTU is up there. All right, so OTU is up there. Let's see what that does for us. Uh-oh. So I want to take all these guys together, and I'm going to group them. This way I can rotate it. So I want it to look like that. Kind of that. And the other thing that I want you to notice is this is U here, right? Well, what do you notice about that? Well, it's in this little triangle. It's also in that big triangle, right? So if we took a look at that big triangle, let's do a different color. The big triangle SCU, U is also in there. So you know that if this is SCU, you know that U has to be congruent to itself by the reflexive property. So now you've got two angles that are congruent to each other. If you have two angles that are congruent to each other, what do you know? Well, you know that the triangles themselves are congruent to each other, right? So, I mean, if we reorientate this, it kind of looks like this, but actually I think there is a flip. So let's flip it. Okay. And now we can rotate it, and for sure it looks like that, right? So obviously you can't read those flipped letters, but this was U, this was T, and well, O, you can read. Okay, so now I said, all right, well, name those corresponding parts. Well, the corresponding parts are things like SU corresponds to OU there, right? And OT corresponds to SC, and CU corresponds to TU. I actually think that I swapped these sides, but that's all right. And then obviously the angles already, S to O is the only one you don't have. You've already got C to T, and you've got U to U, obviously. All right, so maybe a little bit tough to turn that, but a lot of the Regents questions actually do stuff like that. The next one was even tougher. It said, in this rectangle, right? And the rectangle was a big part of this question. In this rectangle, you've got AC, you've got point F on AC, and point E on DC such that it's perpendicular. It wants you to prove that these two triangles are similar. This little triangle, FEC or CEF as they wrote, and ABC up there. So here's the thing, all right? You know it's a rectangle. You know that this side and this side must be congruent because it's a rectangle. This side and this side must be congruent because it's a rectangle, and this also must be congruent based on reflexive property, right? So you're actually going to go through a proof, and you're going to say opposite sides in a rectangle are congruent, right? Given that it's a rectangle, opposite sides in a rectangle are congruent. So I know these are congruent, these are congruent, these are congruent, these are congruent. And I know this is congruent by reflexive property, and that gives you side, side, side. All right, well, why is that helpful? It's helpful because it tells you that triangle ADC is congruent to triangle A or CBA, right? ABC congruent to CBA there. All right. And the reason we want to do this is because we are trying to prove that this triangle here, ABC, is congruent to this little guy here. And we can't do that directly. We have to do it indirectly. And by doing it indirectly, we need to show that it's similar to this triangle ADC, right? And we know if it's similar to this triangle, and, well, if this is the same kind or same exact, right, it's congruent as this one, then they both must be similar to this little guy here, right? So that's why we want to prove those triangles are congruent first. You guys are great with congruent proofs, though, so I'm not super concerned about that. What I am concerned about is, well, let's just get this guy now. They told us this was perpendicular. We know this is perpendicular by the definition of a rectangle, right? So we can go ahead and say, well, all right, we can say we want to do plan, angle, angle, right? If you want to use this first, we can say angle ADC is congruent to angle FEC, right? And your explanation would be, well, I know this is a right angle because all rectangles have right angles. And then this would be, well, FE is perpendicular to CE, and perpendicular lines form right angles, so perpendicular lines, right, form 90-degree angles, right, which are all congruent. Okay, given that perpendicular thing, right? And also we're talking about ADC being a rectangle and having a right angle, right? Or congruent. And you're also going to use ADC is a right angle given definition of a rectangle, right? Also definition of a rectangle. And you guys will obviously clean this up. I'm going through it so the video is not super long. And then that other angle, well, maybe you saw it, maybe you didn't, but C is again in both of those triangles. So angle FCE is congruent to triangle ACD, right? ACD. Why? Well, that reflexive property again. It's been a huge hit for us thus far. All right, reflexive property again. And then you've got your angle-angle theorem for similarity, and we've proved that this triangle is similar to this triangle. But since it is similar to this triangle, and these two we've already proved were congruent, then it also must be similar to this triangle. So all you've done is you've proved triangle FEC similar to triangle ADC by angle-angle similarity, since, right, since these two were proven to be congruent, then you know that also ABC is similar to triangle CEF. It's kind of a convoluted proof, a little circular in nature, but that's really it. You know how to prove congruent triangles, and you know how to prove similar triangles. You just had to put them together. Any questions, always email me. Please like and subscribe.